We've seen subqueries used to generate single values and to generate lists, rows with a single column. Let's look now at subqueries that generate full tables, many rows with many columns, and their use. There are several places where you may use a table-like subquery that produces many rows with many columns. We've already mentioned one case, that of using in with lists of tuples instead of just single values. One may also use a table-like subquery in lieu of a standard table in the from clause of any select statement. Such table-replacing subqueries are called inline views. And one may perform set operations on two or more subqueries to produce a relation that is some set combination, for instance a union or an intersection, of the results of the subqueries. We'll look at online views here and at set operations on subqueries in the next segment. So to create an online view, we put a parenthesized table-like subquery in place of a table name in the from clause. Here's a simple example that illustrates the point. This select is choosing last name not from tables, but from parenthesized subqueries that return table-like results. You can use a subquery, an inline view, in place of a table like this at any point in the from clause, even for multiple joined tables, as in this example. The output of each inline view is treated just like a table by the enclosing SQL query. Each column of the inline view's output is treated as though it were the column of a table. Our two inline views are simple selects on customer and on rating, with aliases CST and RTG. So the effect is the same as if we had used the customer and rating tables directly, really, but much more complex inline views are possible, as we'll see in a bit. Inline views must be parenthesized, and must also be given an alias name so that there's a way to refer to them in the rest of the outer select statement. Now, if the inline view aliases its columns, as RTG does for customer ID, right here, column customer ID, then that alias is the name of the generated column, and that's why we're using CID in the join clause between CST and RTG. Aliasing the columns is optional unless the column is computed, for instance via an aggregation or a subquery, in which case any reference to it in the enclosing query must be through the column's alias. In the enclosing query, an inline view may be used in all respects then, just like an ordinary table. And here, let's run this one to show it working. So, inline views can be highly useful, sometimes even indispensable, for getting complex tasks done in a single query. As an example, let's write a query for database courses 3, the SQL for which is provided with this lecture in courses3.sql. Courses 3 adds down near the bottom here a grade column to takes, and then an average grade column to course. This reflects changes that you made to courses 2 in one of the exercises. It also includes the num sections field that we added to table term in a prior lecture. Now, load courses3.sql and write a courses 3 query that computes the average of grades given across all sections of a given course in a given term. We'll call it the course GPA for the term. And then our query will list, for each term, the highest course GPA for that term. This requires a two-level group by, if you think about it. One group by on course and term to compute course GPAs, and then a second group by on the results of the first one to compute maximum course GPA within each term. Inline views are ideal for this sort of problem. To question 1, write a simple select to list for each term and course combination the ID of the term, the course ID, and the course GPA for that term. No inline views are needed yet. You can do it with a two-table join and a group by. Coming back from the pause. Select term ID, course ID, and average grade, and then I just joined section and takes because they have all the information needed, and then we group by term ID and course ID in combination. Okay, so now let's use this subquery. Run it here first. Bunch of course GPAs there. Let's use this subquery as an inline view in a larger query that lists each term and gives the highest course GPA for any course in that term. Now first we'll need to give a name to the computed column average grade here in the inline view in order to use it in the outer select. And of course we must also give a name to the entire inline view. So we could rename average grade as GPA, for instance, and then perhaps rename the entire inline view course GPA. And once we've done this, we would just treat the inline view as though it is a table in the outer select. We may freely refer to table course GPA with its columns, term ID, course ID, and GPA, just as if it were literally a table that was declared in the following way: course GPA with term ID and course ID and GPA. Now that's not actually going to be there, of course, but we're going to act like it is once we have the inline view. Based on the above discussion, write the outer query to list each term ID and the max course GPA for that term using the answer 1 query with renames as a parenthesized inline view in the from clause. You'll need to join the course GPA table with one other real table. And coming back from a pause there, what I came up with was the following. So we're going to select term ID and max GPA from term, and we're going to join the table term with the interview course GPA, all of this stuff here. And that groups the joined result then by term ID. And when we run it, we wind up with a list of max GPAs per term. Now note that while we could literally have used group by course GPA dot term ID right here, the course GPA qualifier is not needed since column term ID is unique in the two tables, term and course GPA. But had it not been, we could have put that qualifier there. The reference to table section, whose term ID column might conflict right in here, is hidden in the parenthesized inner view. Indeed, referring to section.termID in the outer select would give an error. The guts of an inner view are not evident to the outer query that uses it. The outer query sees only the result. Now let's shift to the Bakery 5 database and try a similarly structured query, this one to find the average receipt total for each customer and then to report per state the highest receipt average. So follow the same approach we just did, first developing an inner view that produces a table, quote unquote, of customer ID and receipt average. This one shouldn't even require a join. Then use that inner view in a larger query to produce a maximum receipt average per state. And coming back from a pause, this is what I got. So we select customer ID average total from receipt group by customer ID, very simple inner view, and then on that a link with customer and group by state, and the net result gives us the maximum average receipts per state. So try one more. Figure out the highest price item on each multi-item receipt. Ignore single item receipts. And then for each customer having at least one multi-item receipt, give their first name, last name, and the average highest price across all their multi-item receipts. As with the earlier example, first start with an inline view showing just information for multi-item receipts and alias any computed columns, and then build a surrounding query that accomplishes the entire task. So we'll do this first step with the inline query in this question and then the surrounding one in the next. So coming back from a pause, looking for just the query on multi-item receipts, what I came up with this, and as you can see, it just does a grouping by price or maximum of price and refers only to receipts that have a count of line items more than one. And so there we go. And then question 5. Join this up with other tables to get the desired final result. And note, by the way, that we have high price as an alias already from max price there. And coming back from a pause there, I have my inner query here embedded, and then join that with customer and receipt, and that in turn grouping by customer ID, and we get our last name, first name, and average high price from that.